Well, hello guys, here Mr. G, and we're going to be doing our first lesson on a momentum. So we're going to be talking about momentum. We're going to study the first topic of the year for grade 12, and I think you should start as early as you can. Grade 12 is tough, it's a lot of work, and it's a long year, so the sooner we started, the better. So now let's imagine you want to cross a street, but there is a truck coming. It's a big truck coming. Obviously you will fear to cross the street because it's a truck coming. All right, if instead of a truck is coming a fly, a mosquito, you will cross the street. You won't worry because it's small, but you will be afraid of a truck. So if it's a truck coming, you won't cross the street because you're afraid of the truck. It's a big object moving towards you. Instead, if it's a mosquito, then you will cross the street. But what if we change the mosquito, and instead of a mosquito, I'm going to have a bullet, and this bullet is coming towards you? Then you will obviously don't cross the street. So it has nothing to do with how big the object is or how small. It is a relation of big and the object moving. Now, what it is? This is the new physical quantity you are going to do in the grade 12, starting with this physical quantity, and that is called momentum. This is a physical quantity that relates both mass and velocity. Watch the video for the explanation of this topic and subscribe. I'll see you at the end of the video. Thank you for watching. I'll see you just after.
Okay, so as we said, this one is going to be the first video related to momentum. Momentum, as we said before also, is going to be the first topic you should do in grade 12. So we're starting a little bit early. This video is going to be small. We are just going to be speaking about the definition of momentum. So let's start by defining or writing the definition of momentum. Now, momentum. Now, by definition, momentum is the product of mass and velocity of an object. Momentum is the product of mass and velocity of an object. The symbol used for momentum is the letter P. It's a small p, but sometimes you can find a capital P and that won't make any change. So this is the symbol we are going to be using for a momentum. Now, momentum is the product of mass, as we said. The symbol for a mass is the M, but it's a symbol you know already. Né? So mass, the symbol is M, and velocity, the symbol of velocity is V. Alright, so if we convert this one into a formula, we have that momentum P is equal to M multiplied by V. Note that momentum, the symbol should have that little R on top. We're going to speak about that one just now, and V as well. So this here is the formula for momentum. And it's not just a formula, but it is the definition of momentum. This one will be given to you. Remember, we're speaking about the linear momentum, in case that there is somebody out of South Africa watching. South Africa, we're speaking about linear momentum. We don't speak about angular momentum, okay? So now this is momentum, and then this is the formula for calculating momentum, which is also the definition for momentum. So if you have the formula, you can write the definition because it's the same one. Now let's look at the unit. Mass, the unit for mass is the kilograms. It is known by you. It is being done before in lower grades, and the unit for velocity is the meters per second. So this is the product of kilogram and meters per second, and therefore that will be the unit for a momentum, will be kilograms meters per second. Remember, this is a product here. That is the unit for a momentum. There we go. That is the unit for momentum. Okay, so far we know the definition of momentum, we know the symbol, we have the formula to calculate momentum, and we have the unit. Now, something important I said we're going to just mention here. And this is a very important fact. Momentum, as you consider the symbol, momentum is a vector. It's a vector quantity. Alright? And therefore, as all vectors done before, momentum need magnitude and direction. Let's move it a little bit up. This one need magnitude and it need direction. So that is important. Later on in the next video we're going to be speaking more about this. Okay, this is going to be a little bit more in details next video. For now we're going to just mention that momentum is a vector. The same happened with velocity, but you know already it's not part of the video. It's also a vector. Okay, so far we know the formula, we know the definition of momentum, we know the unit, and we know that momentum is a vector quantity, therefore the direction must be given in. Now if you study this formula a little bit, we have mass and we also have velocity. So what does it mean? It means that momentum will be directly proportional to mass if velocity is constant. If velocity is constant, then the momentum is going to be directly proportional to mass. What does it mean? If an object or two objects moving at the same velocity, the object that have greater mass will also have greater momentum. Okay? If the objects are moving at constant velocity, that is important. And as you can see in the formula as well, we can see that momentum is directly proportional to velocity of an object. Okay, this is vector, so let's write the vectors here. Now what does it mean? The same as we said before. If the objects have the same mass constant, when I write constant I mean the same. We're talking about two objects that have the same mass. The one that move faster or with a greater velocity will have a greater momentum. This is also very, very important, but it is obvious and it's quite easy because it's coming from the formula. Now, without talking much more, we can now look at one example, a very simple example here, so you understand better this definition of a momentum. Okay. This example said a person of 56 kg is running at 25 km per hour north. Calculate the momentum of the person. Now, from now all the questions we're going to approach the same principle. The first thing we're going to do is to write the data. This is the information that is given to us. First of all, we have the mass of the person, which is equal to 56 kilograms. We have the velocity at which that person is moving, which is 25 kilometers per hour, and it is north. So let's write the direction. It is important, and they ask us to calculate momentum, and this is going to be question mark. Now, before we carry on to do calculation on the formulas, we note that velocity is given in kilometers per hour, like you see here, but we cannot work in kilometers per hour. Note this is a 1, don't you get confused, that is a 1, it's a beautiful 1. Okay, so now how we convert from kilometers per hour to meters per second? All we are going to do to convert is multiply by 1,000, and we are going to divide by 3,600. This is how to convert from kilometers per hour to meters per second. So get your note, get your notebook and write the notes, important note to convert, because many times you will have to convert. Now when you convert, we know that the velocity is going to be equal to 6,94 meters per second north. Okay, this is the one we are going to use, and now we're looking for momentum. It's a very simple question. So momentum, to write the formula now, is going to be equal to mass multiplied by velocity of an object. Now the formula is very important. You have to write it because there is one mark just for the formula. So the mass is 56 kilograms. You don't have to substitute the unit, even though it would be very useful. Multiplied by 6,94. And the answer here is going to be 388. Momentum is equal to 388 and 88,64, remember the unit kilograms meters per second, north. The direction is very important because momentum is a vector and it also have direction. So this is, we're going to stop here. This is going to be the first videos of momentum. If you are able to, if you understand this video, then the first part of the physics for grade 12 is already done. The first lesson or part of the first lesson is already here. So I'll see you next time with the next video. We're going to see the change in momentum and some vector diagram. Thank you for watching. We'll see you next time.
Okay guys, then you survived the first video. This video was very short. It was just the definition of momentum, the unit, the formula, and the relationship between momentum, mass, and velocity, and then important thing, which is one example for you to practice. I hope you take some notes. I'll see you next time. We're going to be speaking about change in momentum, vector diagram for momentum, which could be tricky. Please don't miss the video. Bring a book so you can write some notes. You don't have to watch, the videos are quite short, but it will help you to prepare for the grade 12. Thank you for watching. Subscribe, write messages. I'll see you next time. Mr. G here.